anything session with Jason Hill. Today is going to be a whirlwind. There's been so much going on this last month that we're just really excited to share with you what's been happening at the development centers, multiple of them now. And it's really an exciting time. And I just wanted to take a second to thank each one of you guys for taking the time out of your really busy schedules to be connecting here and following the updates of what's actually going on with Hill Helicopters. We have people literally tuning in from all parts of the world. I'm just looking through the chat of where people are tuning in from, Hong Kong, you name it, all over. And it's incredible to have you each here. Ruben's going to dive in and just give you guys a little bit of an overview of what we're looking at today for schedule. And then we're going to pass the time over to Jason. So great again to have you all here.
That's right, Mischa. We have people from all over the world, all continents. So just checking here, it's incredible. This is getting so much fun every single month. What an experience. Thank you for joining us. And today, Jason's going to update us on the build of the prototype, as usual, where we stand, what's going on, what's the exciting news of the last month. It's going to be for the usual 30 to 40 minutes. And then right after that, we're going to have the Q&A. So ask me anything. It's literally ask me anything. You can put your questions on the chat that you see on your phone or on your desktop. And then Mischa and I are going to be taking turns of asking Jason those questions. So with no further ado, let's just give it to Jason. Jason, welcome, and looking forward to one more update, the May update. Thank you.
Thank you, Ruben. Thank you, ladies and gentlemen, and welcome back to the DC. So we have a whirlwind update for you this evening. There's so much going on from around all areas of the company. I'll try and keep it as concise as I can. I'll focus on the normal 4 areas: a company update on infrastructure and how the company's doing, an update on the development of the airframe as we march towards the first structural prototype. I'll update you on the drivetrain, and then we'll double back and talk about the Digi Cockpit. So if we start with an update from the company, essentially everybody's well aware that Hill Helicopters is really all about developing the helicopter that you've always wanted to own, something more capable, more desirable, and more attainable than you've ever had before, and really bridging the innovation gap between what you can get in, say, for example, the supercar market and what you can get from existing helicopters today, and in meeting our customers' expectations and delivering all of this at a rational price point, empowered by our vertical integration strategy. And when you put all of that together, it should be no surprise that the sales keep on coming in. We're now up to 459 X's, 96 Cs, 555 helicopters in total, so over 50 helicopters in the last month alone. So we're absolutely delighted and continue to be appreciative of the support that we're getting from across the world for our products, and we're working as hard as we possibly can to bring these to market as fast as we possibly can. So that's a brief update on the sales figures. Now, as I think I said last week, and it continues to be the case, Hill Helicopters is not a technology company. We're a company that is industrializing the helicopter. We're the company that makes the business that makes the helicopter. And in doing that, a lot of the time, a lot of the effort, and indeed a lot of the stuff I'm going to show you today is about the endeavors that we're going to build the infrastructure that we need to deliver this helicopter at a price point that's attainable. And there's so much to show you in what's happening with that across this development center, DC2 and DC3. And this might seem like a bit of a distraction, but it's really not, because what this does is it empowers us to go from development into production in the shortest possible time and with complete end-to-end control of our cost base. So let's start with our endeavors to march towards full-scale composite production within the company. So as you can imagine, our aircraft is a big aircraft, and making big aircraft requires big infrastructure. Composites is one of the key cost bases for the company, and so to produce composites at the cost-effective price point that we are, it's important that we not only make the parts, but we also make the patterns, we make the tools, we own everything from one end of the process to the other. Now, I think last week I introduced to you that one of the major pieces of infrastructure that we needed to produce, to install and to procure to develop that was our 5-axis gantry mill. Now, this is a massive machine that allows us to machine the full-scale patterns, and then when we've made the patterns and the tools, it allows us to trim the full-scale parts that we make and even the polycarbonate windows. We've managed to procure, install, commission and get that machine working within the space of a little over a month, and I'm happy to report to you today that that machine is now installed in DC2, as you can see in the video that's comprising of what we've been up to over the last 2 weeks, and as of today we've actually had the machine up and running and everything's working beautifully there. So as of today we're now very close to being able to start cutting the first full-size patterns that are required to produce the first full-scale fuselage. So we expect to see the completion of the handover of this machine to us by the end of this week, and then there's a few peripheral bells and whistles that we need to do to get that running. But essentially the march towards full-scale production of the fuselage is now in full steam. Now, that covers the sort of the patterns and then the tooling, but in addition to that, we need to make parts. And infusion is central to our strategy to make cost-effective composite parts. By being able to buy the material in the lowest possible cost format and add the maximum value in-house, we're able to bring the cost of composites down. And then by eliminating the expensive infrastructure and the long cycle times that are typical in traditional composite methods, we keep the price point of the parts that we deliver down to that which will sort of enable GA 2.0 and get general aviation moving again. So as you will have been following over the last year or so, we've essentially verified that we can produce our carbon fiber monolage as a single part using the 3rd scale demonstrator. And now the very next stage of that process is to produce the full scale tools and to demonstrate that we can produce this thing at full scale. And this, the machine behind me, is essentially what will deliver that for all of us. So what we have here is our brand new CI jet machine, and this is the machine that contains the resin, the hardener, all of the heating apparatus to heat the resin up to the correct temperatures, and then the vacuum and the control systems to be able to take fabric like this, which is how we buy our carbon fiber, lay that into the mold as we've shown you with our 3rd scale model demonstrators, and then this machine infuses those full scale tools to essentially make a full scale version of what you can see over there. So taking raw material in this form, using this kind of technology, and then delivering low cost, aerospace grade, cost effective, properly industrialized composite aerostructures. So we're delighted to have this machine here with us. This is the machine that will make the ground demonstrator vehicles, the structural test articles, the flying prototypes, and ultimately your aircraft. So really pleased to have that here. By the end of this week, that machine will be going over to DC2. And then essentially we'll be ready to start producing in-house infused composite parts at full scale within a matter of a week or so. So really pleased with that. When you're developing an aircraft, there's lots of little jobs that you need to do, lots of bits and pieces. And vertical integration, our strategy that covers all of these things, isn't just limited to how we control the cost of the development process and how we control the cost of manufacturing these things. It's also about how we control scheduling and timescales. And so over the course of the last month or so, we've been investing in a couple of other pieces of equipment that mean no matter how small the job, we've got the capability to do that right here in DC1. So we've invested in a surface grinder, a tool room lathe, and a tool room mill that will be arriving over the next week or two. And this means that as we develop components, if we need to grind a face or make a minor modification to a part, those iterations can be carried out really quickly in-house. And so really that is one of the key strategies and one of the key points to remember with what we're doing with vertical integration. It's not just about the manufacturing, it's also about how we control the timescales across everything that we do. So really pleased to have those bits of kits arriving very shortly soon. I also mentioned last month that we'd procured a CMM measurement machine. The precision engineering that goes into a helicopter in the form of the bearings, in the form of the gears, in the form of the gearbox, the casings, the bell cranks, the hydraulics, all these sorts of things are dimensionally critical. It's not only good enough to make these things on high precision machines, you also have to make sure that you've made what you thought you made. And so for that reason, we have to use equipment like CMM machines that give us a semi-automated or a fully automated way of measuring and proving that we've made what we think we have. Now, that machine, as you can see, was delivered today. And over the course of the last week, what we've essentially done is installed a temperature-controlled metrology lab in DC1 here. So our precision machining equipment lives over that side of the hangar, and then just the other side over here, we've built this special purpose room, and the purpose of this is to create an enclosure. It hasn't got its glass front yet, that comes next week, but an enclosure that's air conditioned that allows us to control the temperature of all of the parts that we measure, and more importantly, the computer measurement equipment that we use, because when you're measuring down to microns, even the warmth of your hands on the parts can make a significant difference to the measurements that you take. So as we measure things, they have to come into here, stabilize at a temperature, and then they go onto the CMM machine, and this machine can go and probe round them according to a pre-programmed route and measure exactly what we've made. So not only can we produce the precision parts in-house, we can also measure and qualify that they are what we think they are. And this too will dramatically reduce the time it takes for us to go through the iterative process of getting those parts that we're manufacturing up to aerospace grades, not only of performance, but of repeatability, and to get the control and the process performance to where it needs to be to enable us to produce these parts in production. So very excited to have this here. The glazing that fronts this building and finishes the enclosure will be here next week, and as soon as that's in, the guys can come back and finish commissioning the CMM machine, and then we're good to go with that. So very swift progress on that, very pleased to have that installed. So moving on. One of the questions that we're getting asked increasingly on the sales presentations, and I get asked a lot when people come and visit the DC, is about the challenges of the supply chain, the availability and cost of materials, and the impact that the challenging global conditions that we're all living through, the pandemic and the current conflict in Ukraine, is having on what we're doing. We're in a very privileged position at the moment in that we don't actually require a lot of material to do the development. A lot of the material quantities that we need are routinely held in stock by stock holding organizations. And so in terms of its impact on the development program, we're not really feeling that. We're not immune to it, but we're resilient is how I would describe it. We're not having any difficulties in getting materials at the moment. Some of the materials are more expensive. The titanium that I shall show you a little bit later, for example, has jumped up in price by about a factor of 2. The nickel alloys that we need for some of the components of the engine are obviously very expensive at the moment. But the other point I would make is we really don't need a lot of those materials per aircraft. The vast majority of the materials that go into the aircraft are much more conventional grades of alloy steels and stainless steels and stuff that's much more widely available. But I thought, just to kind of reassure you, what I might do is just take you over and show you some of the material that's just been received in goods inwards, so that you can see that for the immediate tasks that we've got on at the moment, we've got everything that we need. So this was a batch of demonstration steel. So this is just engineering grade steel that we've got here that we bought in to allow us to work through all of the development and machining development processes for all of the gear cutting. So there is enough steel here to make multiple examples of every single gear in the prototype aircraft. So this gets us all the way to the point where we can build a whole transmission for the aircraft. This gear, this stuff over here is similar. This is actually the billet from which we make the big ring gear in the base of the epicyclic gearbox. And so when you see the size of that, you can see the lengths that we've had to go to get the weight out of this sort of stuff. And then right in front of you, this is half of the the stock of extremely high grade, rather too high grade, as I think I'll explain later, titanium that we've bought for producing the titanium impellers. So we've got one of these billets on our machine at the moment. There's one down at Seco, and I'm hanging on to one of them in my office because they're quite expensive. And then over here, this is the first of the steel for the airworthy gears. So this is the aerospace grade gear steel, and again we've got enough for the first wave of test gears that are going on the first test gearbox. So just to point out, we're not having any difficulties getting materials. At the moment we only need small quantities, which makes it much easier, and then as we ramp up into production we still don't expect to have major problems because the particularly difficult alloys that we only need in small quantities, and the commodity alloys are still pretty broadly available. So I hope you find that reassuring. It's not really materially impacting us at the moment. Okay. So in addition to the development of the infrastructure that I've shown you, obviously we're now having to grow our production team as well. We're getting to the point now where we're increasingly moving away from the design, well, not moving away, but moving from design into technology development, process development, and manufacture of these parts and systems. And so in order to do that, as the company becomes increasingly focused on production, we're having to recruit lots more staff to support that. So I introduced you last week that we'd taken on a new machinist, Mick, that's been busy producing gears and gear blanks for us, working with Mark. And then this week we've had our new lead composites production engineer that you can see there talking to Tim. He started this week and has taken charge of essentially bringing DC2 up to operational levels. So he's looking after getting all of the materials we need for the full-scale fuselage, getting all of the patterns made, and all of the other good stuff that I'll introduce to you in a bit. And then on top of that, Dave is now looking after recruiting the range of composite production staff that we're going to need as we ramp up towards producing not just the first prototype aircraft, but subsequent aircraft and then subsequent production aircraft after that. So excited to see all of that coming along. Many of you will be aware that we've now been joined by Claire Barber. She's been appointed as our customer relationship manager. She's now the first point of contact for all of your needs when you interface with the company, and she'll be there to make sure that you all receive the personalized care and treatment in a prompt manner that you all well deserve. And then on top of that, we will also, because of the increasing numbers of customers that we've got and the increasing pressures of my time to drive the development, we're now starting to implement a more streamlined approach to factory visits. So people are still welcome, but we're being a little bit more robust and rigid about when people can come, and Claire will be handling that and making sure that people are booked in correctly. So look forward to seeing more of you soon in those sessions. So one of the other things that we're having to be very careful about, and it's one of the things that it's very easy not to think about when you're focused on an engineering and a production program, is the development of the business itself. Through the support that we've had from you guys, our business has experienced extremely rapid growth. We've grown massively in headcount, in facilities, in infrastructure, in management of inventory, even down to the complexity of everything that goes on within the business. All areas of the business are developing very rapidly, and for that reason, we've had to develop a lot of the business processes as well to make sure that we grow in a disciplined manner. So not a lot of our time, but a significant amount of time at the moment is being taken in making sure that we communicate better across the business, making sure that our business processes are able to essentially manage the transition into manufacture and into being a production organization effectively, and essentially make sure we grow in a disciplined way so we continue to be effective in what we're doing. So let's move on now and talk about the progress that we're making with the airframe. So over the course of the last month, we've been updating you on a lot of the details, death by 1,000 details, all of the things that you need to get right before you're in a position to freeze the aircraft design and go and cut patterns and make tools. And as well as being an aerostructure, the airframe is the thing that absolutely everything else attaches to. So even when it looks finished, you find that there's a million little details that you've got to engineer in before you can properly freeze it and say, right, let's go to tooling. And a lot of effort over the last month has been spent baking in those details, getting them right, so that when we make this fuselage, it's got everything that it needs to be able to function not only as a structure, but as an airframe system. So a lot of work has gone on over the course of the last month or so on the recesses and the interfaces of all of the components that attach to the fuselage. Now that is now maturing very, very nicely, and essentially most of those are completely frozen. One of the areas that took a little longer than we expected but has matured very nicely is the door hinges. We've been at great pains to make sure that we maintain this flush exterior to protect our drag performance and make sure that the aircraft delivers the forward flight performance that you all want. But that's led to a whole host of complexity that's had to be baked into the airframe. We've also been taking great care to make sure that we manage the stiffness of the doors and the performance of the seals that go around the door. So we're using, when we create a carbon fiber flange around the door, we're using an automotive style seal to make sure that we can properly seal our composite panels against the airframe and the door, and that we've properly managed the stiffness of both the door and the airframe to compress this seal to just the right level to give the right degree of draft exclusion and water tightness during all regimes of flight. So although these things look trivially simple, there's so much detail involved in this, and if you get it wrong, it just doesn't work right. So there's been a lot of work going on to bake that into the design and make sure that all of that sort of stuff works properly for you. Other details that we haven't been too explicit about to date are the door handles, the door closing mechanism, the latching mechanism, all of these sorts of things that are necessary to make the experience of flying the helicopter what it needs to be. I think lots of people are familiar with helicopter doors where you either have to bolt them or slam doors, and slam doors don't work well in helicopters because slam doors rely on the weight of the door to be able to close the door against quite a large seal force, and if you take the weight away, it sounds like a barn door or a shed door when you shut it. And so we've been doing a lot of work on designing a locking mechanism that won't be quite as good as a soft closed door, but will be the next best thing, where you can essentially latch the door, and then we use an over center mechanism that we've essentially extracted from a mechanism that's used elsewhere in industry, where essentially when the door stay comes in, it essentially pops through an over center spring and then triggers a second spring that pulls the locking pin into position. So the moment you trigger that pin, it'll pull the door against the seal and give you a nice positive door closing action. So we've been busy developing the locking mechanism behind that, developing all of the integration of that into the doors, and then making sure that all of those kinds of details are baked in properly into the fuselage. One of the other developments that we've baked into the fuselage over the course of the month is the fuel filler. And I think the updated CAD for that was only produced today, so it didn't make it into my presentation. But we've moved the fuel filler from the roof of the aircraft down into the space that you can see just above the top of the baggage bay door. So rather than needing a separate opening flap on the exterior of the airframe, when you open the baggage bay door, you'll be presented with the fuel filler and all of the fences and troughs and drains that you need to prevent contamination of fuel into anywhere that you wouldn't want it. But that gives us a nice, clean exterior, and of course a fuel filler that's much easier to access than what you might be used to on many contemporary helicopters. The other advantage that this gives us, and it's not something that we've implemented yet, but it gives us a very simple mechanism of providing a visual guide for checking your fuel level, just as you would with your oil levels and your other fluid levels within the aircraft. So a nice, simple, fail-safe way of knowing exactly what the fuel state is when you do your walk around. So pleased to see all of that come together. I introduced last month that the guys down at Composite Integration were busy infusing the second of the third scale demonstrator fuselages with all of the the key details of the manufacturing process baked in. That was successfully completed at the start of the month. We've achieved an excellent surface finish. We've managed to get outstanding cosmetic edge definition. So all of the sharp edges that you want around the recesses for the doors, around the recesses for the windows, and around all of those sorts of things, those are nice and cleanly integrated into the fuselage now. The lightning strike mesh has gone in without difficulty, and we've optimized the layup and the lamination process for handling the dry fabric that I showed you over there. All of those sorts of things are working beautifully, and so not only are we now in a position where we've got the equipment, the gantry mill and the gantry mill and the infusion system, we've got the patterns on the way, we've also got all of the process parameters for the infusion tied down to where we need them now. So delighted to see all that come together at just the right time. So now it's time to get serious. We've proven the technology, we've got all the kit in place, now it's time to go to full scale. So it's a very, very exciting time to be at the company at the moment. Tim has just about finished baking in the last of the straggling details into the A-frame, and is now full steam ahead in producing the patterns from which we can make the tools, from which we can make the first fuselage for the ground demonstrator vehicle. So that is now that is now going ahead right away. We've come up with a new way of making the patterns, so it's slightly different from how we did it on the third scale in terms of how we split the parts to try and make the layup processes easier. So again, learnings that we've taken from the third scale demonstrator have been baked into the full scale approach that we're taking. In parallel with that, Dave is implementing all of the infrastructure we need to physically be able to make these patterns. We've got a very large number of patterns to make, a very large number of tools to make just for the primary airframe, let alone the bulkheads, the doors, the cabin doors, the cowlings, and all the other things that we have to do, including the interior panels. That's now marching ahead at full steam with primary focus on the aerostructure so that we can get that built and get that on test. And then DC2 is being prepped to be able to carry out all of that work in parallel with these activities. So just as a quick recap of the pattern and tooling technology that we're using to deliver this, you'll recall from previous presentations that in order to control the cost and in order to give us the flexibility to iterate and optimize these tools, we've essentially pulled in tooling technologies from other areas of composite. So we take a standard base that conveniently fits onto our gantry mill. We put a flat board on the bottom, block up some polystyrene, high density polystyrene foam, and then we cut the basic shape of the pattern we want. That then gets sealed with a layer of hand laid up glass fiber, and then over the top of that we apply our tooling paste, which when cured goes back onto the gantry mill and machines the finished tooling surface that you can see in that pattern. And this gives us a huge cost advantage to the cost of the patterns, to the cost of the tooling, and also to the rate at which we can make these components, because we have complete control end to end of every element of that process. The only challenge with that, of course, is it is a huge task. And so one of the things that Dave is doing at the moment is bringing together the body of people that are required to do that fast enough to meet our timescales. In parallel with these activities, we've also carried out a full survey of the gantry mill and have got the post processor that we need to get our CAM software to be able to drive the machine. So we can take our patterns directly from CAD into CAM and automatically develop the tooling paths that are required to produce these patterns. So it's about as automated and effective and time efficient as the process could possibly be. And the physical machine will be operational by the weekend, and we expect the post-processor and the software side of it to be with us at some point next week. So by the end of next week, we will be in a position from a manufacturing perspective to start cutting the first of these patterns. We discussed at length last month a lot of the efforts that we'd been going to develop the in-house glazing manufacturing processes. We'd looked at drape forming, and we'd also in parallel looking at vacuum forming for the production process. Over the course of this month, we've taken our tooling and we've been carrying out some vacuum forming trials to optimize the process parameters and to optimize the quality and the finish of producing these high integrity, impact resistant windshields that we need. And what you can see here is a like for like part being produced for the ones we did here using drape forming. There are a couple of little niggles that we need to get over to tune the tooling, to tune the process parameters, but essentially the process works straight out of the box. And off the back of that, we've commissioned the full-scale tooling for the windows, and we've actually started the production now of the full-scale windshields for the first fuselage that we produce. So not only is the full-scale fuselage now on its journey to production, we've also started the windshield as well during the course of the month. On top of that, we talked a little bit last month about the work that was ongoing for some of the supporting processes that we need to implement these windshields on our composite fuselage. And there were a number of things that we were developing there. We'd come up with the adhesive strategy working in partnership with 3M, and they were waiting for some samples from us for our adhesive primer layer that goes on the back of the windows. We've now completed the production of the test panels for these things here. And so this black layer here, it isn't a paint, it's essentially an adhesive primer layer. And that allows us to squirt the adhesive onto the airframe, place the glazing onto the outside, and of course you can't see through the blackout. So it gives you that nice defined finish that you're used to seeing on your cars. And then we also have the ability to add little bits of graphics around the edges just to tidy up the way that looks and get that really to the level of fit and finish that you'd expect from automotive production processes. So very pleased with how all of that's come together during the course of the month as well. So let's move on now and talk about progress that we've been making on the GT50 turbine engine. This is the heart and soul of the aircraft, and something that's been receiving a huge amount of concerted attention over the course of the last month. Our strategy with the development of the engine remains the same. 3 parallel tracks, extensive effort going into the aerothermal optimization of the engine. In parallel with developing the manufacturing processes, we've done an awful lot of work this month on the titanium compressor and the titanium manufacturing processes, amongst other things, and I'll show you a little bit about that later, as well as developing some of the peripheral systems, some of the casings, and some of the other hardware that needs to go into the engine. So one of the biggest wins over the course of this month is that we've managed to get a particularly troublesome package of analysis work done that is necessary to hook up the performance model, the secondary air system model, and feed into all of our final stress and lifing calculations. Designing jet engines is not for kids, it's serious business, and the devil is very much in the detail. If you don't chase down every little detail, if you don't get the thermal stresses right, if you don't get the thermal transients right, if you don't get the tip clearances and the gaps right, the engine just won't work. And it's much, much quicker to optimize and develop that while we're still on the computer than trying to build an engine that you then have a rat's nest of problems with. And over the course of this month, Saif has managed to get all of the CFD calculations to work. So we're now in a position where that data, that high fidelity aerothermal data from throughout the gas path, can now be fed back into the performance model, back into the secondary air system model, and through all the remaining stress and lifing analysis, so that we can freeze the last components in the engine and get those over into manufacturing, get that thing onto the bench. So I can't begin to tell you, I've spent 15 years doing this sort of stuff, and I can't begin to tell you how awkward this particular case has been. But we've solved it, we've got it working, and we're delighted to say that that's now moving forward at pace. So what that now means is we have a working performance model that gives us all of our operational characteristics for the engine. It also gives us all of the characteristics that we need to design the algorithms that the FADEC system runs on. We've now got the in-feed information to the secondary air system model that allows us to balance all of those delicate flows in the heart of the engine that keep the important bits nice and cool, prevent your oil from coking, and make sure the hot gases stay away from the precision parts in the middle of the engine. That then means that the final bits of FEA can be done throughout the engine, and the very last bit is the coupled transient analysis of the whole engine system that allows us to optimize tip clearances, protect that performance, and protect the life of the engine. So delighted now to see all of that stuff coming off the production line. And off the back of that, we've now been able to really push forward and finalize a number of areas of the mechanical design of the engine that were really pending that insight that the analysis gives. So the fuel system is now maturing very nicely, along with the annular combustor. As you remember, we developed a whole range of production equipment and kicked off some production trials on the annular combustor. And we've had the first of these specimens in. So this is the very first of the super alloy rings that we've had manufactured, and it is a series of these rings that are welded together that make the outside casing of the annular combustor. And the way these are made is we buy this sheet nickel super alloy in flat material. It's then welded, the weld is dressed back, and then this goes onto a specialist piece of equipment that we've manufactured to stretch it to size and to make sure that it's properly round and concentric. Once that's done, then these things can be rolled to produce the curving, the form that we need for the cooling channels that keep these high temperature alloys bathed in cooling air so that they can survive the searing temperatures that exist within the engine. So delighted to have those with us. Mark's going to take these off now to get them rolled, and then we can stretch them and complete the remaining parts of the manufacturing verification of that. So delighted to have that. I did mean to bring a fuel nozzle down with me, and I forgot to put that on my table. But we've actually had the first of the fuel nozzles in. What you can see on the back of the annular combustor there on the slide is the implementation of the fuel nozzle, the air blast nozzle, and all of the fuel pipes that have now been laid out around the back of the new combustor. There's a little bit of work going on at the moment on the final form of those casings, pending the outcome of the analysis we're doing at the moment. But then once that's done, that whole design can be frozen, at which point we'll also have all of the manufacturing processes nailed to be able to produce all of this. So very, very pleased with how all of that's coming together as well. In other big news, the electromechanical design of the starter generator has matured beautifully over the course of the month. I've previously showed you how the electrical design of our starter generator, which is a direct drive starter generator on the end of the gas generator shaft, has matured and has delivered or exceeded in many respects on all of the performance requirements. Over the course of the last month, Rich has been developing the mechanical embodiment of that system. So how we support it, how we cool it, how we encase it, how we keep the oil sealed from around it, and that part of the work has now been completed. And to put this in perspective, the complete weight of our MGU unit is a little over 3 kilograms. A traditional MGU unit running at a much slower speed is 10, and that's without taking into consideration the weight of the reduction gears that you need in the engine to be able to drive it at a lower speed. So this is a massive weight saving for our engine, and we're really pleased to see how this is coming together. It's essentially making the engine lighter, simpler, and more reliable than previous generations of these engines. So we need one final pass through the rotor dynamics on that, and then essentially we're frozen mechanically and electrically. Now, the big news in terms of the engine this month is I introduced that the final 9+9 design had been completed at the end of last month, and we were just about ready to start machining it. We've now completed the machining of our actual 9+9 compressor. So this includes the Curvix connections on the front, and also the back of the impeller. It includes the land for the labyrinth seals, though there may be some design changes on that coming with a new SAS system, and the actual blade geometry. We've now optimized this process. We've optimized the production process that supports it, and we've also gone on and developed the inspection process. So we've taken this impeller, it's actually been returned to us today, and it was measured on the CMM machine that I've just introduced to you over there before it was shipped to us. So we now have a fully developed process for manufacturing the in-house compressor wheels, and every element of that process has met or exceeded my expectations. So the price point, cycle times, the effectiveness of our vertical integration strategy has proven to be exactly what we thought it would be. So absolutely delighted with the progress that we've made this month on the compressor. I'm going to talk now a little bit about the next step, which is titanium, but everything that you've seen there applies equally well to the next step in the engine, which is the turbine blisks and nozzles. So I mentioned at the end of last month that our tooling partner had partnered with us on what we called our titanium accelerator program. Now, titanium is a very difficult material to machine at the best of times. It's extremely hard, it's extremely difficult to cut, it's very tough, and it has particularly unpleasant characteristics for making swarf rather than chips. And so in order to optimize that and to shortcut the process development that we'd need to do here, we partnered with Seiko and sent a billet of the material down to Seiko for them to do the first process optimization and tooling selection operations for us. That work has been completed successfully. One of the findings is, in order to get to the performance that we needed to get to for our compressor, we've currently ended up with an extremely high grade of titanium that is spectacularly difficult to cut. And so there's some work going on within the engine team at the moment to see if we can tweak the secondary air system to back that grade off a little bit. This the stuff I'm going to show you in a minute is basically twice as difficult to cut as the conventional aerospace grade of titanium. So we've had to do quite a lot of development to get that stuff to cut, and it will require specialist equipment to cut it all. So essentially, the problem that we've got with the material at the moment is titanium likes to create swarf. It's this strong, tangled wire that wraps around the tool, it wraps around the lathe itself, and it just gets in the way everywhere. In order to make conventional chips, which is what you'd want the material to break up into, you need extremely high coolant pressure, you need extremely specialist nozzle details and specialist tooling. And so Seiko are busy developing all of that to optimize the actual production process. But in the meantime, in order to sidestep that program, we've been doing some work whereby we've milled the blank, or we're starting to mill the blank as we did with the early aluminium compressors, to avoid the swarf problem. So what you can see here, this is one of the titanium billets that I introduced you to earlier, and what we're doing here is, rather than using the lathe to cut the first operation, which incurs all those problems, we're taking the stock material away with a miller, which quite happily, although it's not beautiful swarf, it'll still make chips rather than swarf that doesn't get in the way of the cutting process. So I can assure you this is a revolting material to cut. It's quite challenging at the best of times, but using the process that we laid out for the aluminium the aluminium compressors, where we developed the work holding and all of the necessary equipment to make it on the miller, we're able to sidestep the problem to get the titanium impeller into production and onto the test bench as soon as possible. So those two streams of the program are working in parallel to keep us heading towards an engine on a bench on time. So pleased with how that's developing. So let's talk a little bit about one of the other big areas, which is our transmission development. Now, as I keep saying, the jewelry in the helicopter, the mechanical jewelry, is the gears, the bearings, and those mechanical bits. A helicopter is far more a machine than it is an aircraft. I outlined the 5-stage, 188-step program that we developed to get to flight gears, and we are absolutely flying through that program at the moment. All of the material, all of the tools, all of the work holding, everything that we need is in stock here at the factory. The machines are working a treat. Craig's finished all of the drawings and the process specifications, and Mark is powering through the manufacture of the test gears. So we've now completed the first fatigue gear. That's been roughed in-house, it's been finished machine in-house, and it's been sent out and inspected. And we are about that far away from hitting all of the tolerances we need to clear that gear. We have a small issue with run out at the moment, which is to do with how the work holding is centered on the machine. machine. And between Mark and Craig and the guys at Dontine, they know what's wrong with that, and they've just got to get that teed up on the machine a little bit better. In addition to that machine, the spur gear that you've seen before, the very next step is to start producing other gears within the aircraft. So what you can see over here is this is the drive pinion for the main rotor gearbox. So this gear has already been roughed. It's been sent out for heat treatment. So this has the hard shell on the tooth faces that we require to be able to deliver the performance that we need and the durability that we need in service. This gear's come back, and that one's now ready to be hard machined. We're just waiting for a slot on the machine. We've also produced the first of the blanks for your planets. So in the epicyclic gearbox, that's the size of the 3 planets that go around the mast and the ring gear. So the first one of those is now in production. We're producing further tail rotor gears so that we can get these out to hardening and get the fine material trials on. And I think I introduced that we'd got some very specialist work holding coming on that can hold the centers on these gears on the machines down to single figure microns. It's so important that these things are registered on the machine really accurately so that we can hit those tolerances on the teeth, and that's all working really well at the moment. So very pleased with that. I think the other thing that I want to point out as well as doing the technical development, how you cut these gears, how you harden them, how you control the process, we're also making sure that we develop all of the productionization processes and maximize the learning from this as we go along. So all of these things that you can see here represent the work that we're doing to make sure that the production process is properly optimized. So one of the things that Mick has been involved with over the course of the last week is optimizing all of the cutting cycles for producing the blanks so we can get the shortest cycle times, the maximum productivity out of the machines, and drive the cost of these gears down to the absolute minimum. And what that means for our customers is very simple. Essentially, we can produce these gears with this equipment at about half of the price in prototype quantities of the nearest subcontract organization. That's not even an aerospace subcontractor. And then on top of that, when we go up into production, that drops to a quarter of the price. So vertical integration is working. Even at these early stages, we see it in the costings that we've done based on the products that we make right here. So really pleased to see all of that coming together very nicely. And then I just want to round up on the progress that we've made over the course of the month on the Cockpit. The digital cockpit, the decision has been made essentially to go for 3 15.6-inch screens with hosted navigation apps on the center screen in a sandbox module. That can either be an M1 based platform or an Android based platform, so that we can cover the full range of navigation apps that are required around the world. We've done some work with 4Flight and with Oz Runways as test partners over the course of the last month, and I have to say these apps look incredible on the big screen. The additional real estate, the ease of use and the size of these things in the cockpit makes it a totally different experience, and so we're absolutely convinced that this is the right thing to do for a next generation VFR flying experience. There's a few details that we need to sort out. There's a lot of technical details that are being worked on by Martin and the team at the moment, but this has now triggered the final wave of UI development and a minor respin of the cockpit to suit this new topology. But I have to say, I think you'll be blown away when you see it. We're really pleased with it. And finally, I reported last month that Martin had been doing some antenna testing. That's now been extended to the like-for-like testing on the embedded antennas within the end plates of the horizontal stabilizer, and the performance is really very impressive. We have a little bit of work to do to linearize the response over the VFR frequency range, but other than that, it works absolutely fantastically. So very pleased with that. One final question that I'd like to answer for people before we launch into the questions is the fact that we've received a lot of queries and concerns about the availability of insurance. We've been working over the course of the last month to start engaging with insurance brokers and with insurance underwriters. And we're still at the very early stages, but both us and the brokers that we're dealing with are very confident that we're going to be able to deliver cost-effective insurance. We've started with the US as one of the more difficult territories around the world. And fundamentally, the insurer's view is very much the same as ours. The approach that we've taken to our risk mitigation strategy with an aircraft designed specifically for low-time owner private pilots, the workload reduction through the Cockpit, and then all of the active safety management stuff that we've implemented really helps with managing the risk, as well as the part underwriting that we're doing on the hulls as well. So I can assure you that that is in hand and that we don't anticipate any major difficulties in delivering cost-effective insurance around the world. So on that note, I shall pause for breath and invite you to ask any questions that you might have. Thank you for your attention.
Thank you, Jason, for another comprehensive and detailed update. You know what? I was thinking here during your update that I don't remember any other company in history has done this so much openness and transparency of every single month, letting everybody know where we stand on the build of the aircraft. Great to have another update from you, Jason. Now we're going to get into the Ask Me Anything part, and it's literally everything is possible. You can ask anything you want. You will see on your iPhone or phone or whatever device you're going to have, or desktop, that you can have a chat window, and there you'll be writing your questions. We have a lot of them already, but you can write those there, and then Mischa and I will take turns to address those to Jason. So let's go for it. Mischa, you can start with your first one.
Sure, sounds good. The first question is from Edward, and it says, the fuel indicator on Robinsons and other helicopters are famously unreliable or inaccurate. Will there be a better fuel system for the HX50 for the indicator of level of fuel?
Yeah, the fuel indicator in HX50 will be as good as is practical to do so. I mean, it is fundamentally a level-based system, and it's a level-based system in a complex-shaped tank with an aircraft that pitches and rolls all over the place. So there are some fundamental limitations to what can be realistically achieved, but yes, it's as accurate as a fuel indicator can be.
All right, from Stuart, we have a question. Are the headsets going to be wireless?
Oh, I would love wireless headsets. At the moment, they're wired, but as soon as I can make them wireless, I will.
Okay. Another question, or a question from Rupert. Do you have any detail, or when are we going to start seeing detailed visuals for the soft ground handling kit and the estimated of the speed compromise between the skids and the retractable wheels?
In all honesty, we should have had the speed thing done by now. The proposal for the bit of work to do that is still on my desk, and I haven't signed it off yet. So as soon as I go upstairs and sign that bit of paper, the work will be done. So give me a month. We maybe get that done for the next update in terms of the speed penalty. In terms of details for the bare pores, I'm afraid that is going to be a little bit down the line. The options are on the back burner at the moment while we drive through the detail of getting the fundamental aircraft done. As you can see from the level of detail that I take you into in these presentations, there's a whole world of work going on to not only develop the aircraft, but also all of the infrastructure, the processes that we need to get it into production quickly and to get it into production in a reliable and repeatable fashion. And so that has to be the focus at the moment. As soon as those critical things are done, we'll push on with the optional kit. So we haven't forgotten it. Nothing that's on the list has dropped off. It's just a little bit down the priorities list at the moment.
All right. Now we have a financial question from Nigel, which is from the sales deposits and grants, what is the total money you have had in, and how much have you spent to date, and what's remaining on the account today? So a little bit specific. Let's see what you want to share there, but certainly I can have a little bit of comfort there, Jason.
Lots is the answer. I think we've had about 30 million in in orders received in terms of the deposits. We have a little bit of money outstanding from that, and I think we've with all the infrastructure and the development to date over the last 2 years, we've spent just under 10 million. So we've got lots and lots of money.
Excellent.
Okay. The next question is from Dimitri, and he says, I would like to hear a little bit more about the UX, UI, and acoustic experience.
The acoustic experience is a simple one to answer. It's going to be broadly similar to what you would expect in helicopters today. We're not attempting to insulate the cabin the way you would in a massive VIP helicopter, because the weight penalty associated with those acoustic lining materials and techniques is too much for a little helicopter. The way they get away with it in bigger machines is they trade off payload for some of that extra stuff. But we're already putting a relatively heavy car-like interior into the cabin, so you will still need active noise cancelling headsets, which is why they've been specified. But the quality of the gearbox means that the transmission noise that gets through is fairly modest by conventional helicopter standards. The engine is a very modern design with very well-engineered aerodynamic components, so the noise from the engine is again comparable with more modern helicopter turboshaft engines. But that realistically is about as good as it's going to get in terms of the mechanical noise in the engine. In terms of the rotor noise, as I've said before, our rotor topology, both in terms of the main rotor and the tail rotor, is very similar to that of an EC120. So you can expect an acoustic signature similar to that. In terms of the UI, the recent move to 3 screens has opened up some wonderful new opportunities for us, where we can let the electronic flight books and the nav apps do what they're really good at. And I've been lucky enough to see some of the things that are coming up in future generations of those products, and quite frankly, we can't compete with that. Those guys are so good at what they do that we would be foolhardy to try and duplicate any of that stuff. And so we're going to let those guys do what they're good at and just provide a better way of accessing that within the cockpit in the form of this big touch screen. We've also had some thoughts about other ways that you can interact with the touch screen, but I'm not prepared to disclose those just yet. In terms of our UX is very much about simplifying the VFR flying experience. We only provide the information that you need. We only present the information when you need it, and we let the computers do the rest for you. So if you need to be alerted to something, the UI will alert you. I don't want you bombarded with lots of superfluous green indications. All that does is consume brain power and give you less time to look outside, less time to navigate, less time to communicate. That's not what's best for a low time inexperienced pilot. So our UX is all about making VFR flying easier, reducing the workload, and making it as engaging and enjoyable as we possibly can. We've just kicked off another big chunk of UI development work, and so you can expect more updates on that as we approach the summer. And we're aiming to do a fairly large reveal of the new Digi Cockpit in the summer as well. So I don't want to spoil that.
Right, Gaten is asking, we start to see airframe parachutes for garage copters and light helicopters. Would it be considered as a security option?
I would never say no to anything, but personally, I don't like the idea. A helicopter in auto rotation comes down slower than a parachute and gives you full control, and it's full control that you're trained how to use. So personally, I think a helicopter that's been designed to auto rotate well, with a pilot that's properly trained, is a better solution than a parachute. I think in practice, if you were in such a state that you'd lost your rotor RPM and you felt it necessary to deploy a parachute, I don't know how practical it would be to deploy a parachute with low spinning blades flailing around, with the helicopter in a strange attitude. And helicopters typically fly so close to the ground, I don't know that you would have time to get it out anyway. So I'm not convinced it would, in practice, add much of a safety benefit. I get the idea that if all your important mechanical bits up the top break, then there's some argument that it could benefit you there. But I think in most cases it may cause more harm than good. So I'm not a believer that it's the right thing to do. But if the manufacturers that have adopted that approach demonstrate that in service it really helps, then by all means we'll consider it.
Okay, are you from John? Are you considering a carbon fiber finish or a wrap?
You could certainly have it wrapped. That's certainly a possibility. In terms of a carbon fiber finish, originally when Dino asked, I said no, because practical carbon fiber isn't always pretty. You know, we've got an industrialized fuselage here that's designed to deliver performance, reliability at a price point. And when automotive companies do show carbon fiber, it's often an extra layer of carbon that goes in purely to be aesthetic. Now, we can't afford the weight of that, or you wouldn't want the weight of that. And so it's much more difficult to deliver the finish that people would want to see. All of that said, they have done an amazing job on the second, third scale. And so once we've got some experience and we've optimized the full scale fuselage, we'll take a more educated view on that. If we can get the finish to where it would need to be, not in terms of ply alignment or consistency, but it's just where different plies meet and overlay each other. It's those areas that we need to be sure we can get that up to the level of finish that people would expect. Otherwise, it won't deliver the look that they want. So we'll see what we can do. I won't rule it out like I did originally, but don't bank on it. I think practicalities will probably have to dominate on this occasion.
Next question from Gareth. I'm not sure if this one I understood, and I'm not sure if you are able to answer it in public here, if I understood it correctly. Let's see. Could you give us a brief overview on the end ready to fly as such consumer cost of a complete airworthy ship? I don't know if he's asking how much does it cost to build, what is the cost?
Yeah,
I'm not sure
if it's the cost to build, there's no way I'm telling you that.
Yes, all right.
That's the one little thing you can't ask me.
There you go. So that's a good answer.
If it's a question on what we touched on earlier, how are we being affected by inflation in material prices? How are we being affected by the knock-on cost of living increases and things? We've got plenty of headroom to absorb that. And the price point where we've pitched the helicopter is important to me for my GA 2.0 strategy for sort of pushing this out to a broader market that we've seen before. So I'm robust about my costings. Everything that we've been doing here on the shop floor has met or exceeded my expectations. I have told some people in private how much I expect those fuselages to make, but I'm not going to say that publicly.
Very good.
Sorry, how much I expect those fuselages to cost to make is what I was trying to say.
Yes. Neil's asking a question and dovetails well with what you just said. Are you confident that the engine is going to achieve the power that you have hoped?
Yeah, power's easy. Power's easy. In order of difficulty, you can get to power. You can be very dirty and crude and get to power. Efficiency is the next challenge because you've got to get all of the little details right within the engine so that the tip clearances are right, the seal clearances are right, the aerodynamic performance is right. And then the next problem that you've got after that is dealing with the cyclic life and reliability of the engine and the little niggly problems. So I'm not worried about performance. To me, that's a no-brainer. And the guys that we've got working for us in the engine team have done all of this many, many times before. We will get to the power, we will get to the efficiency, and we'll get to the reliability. But I'm more worried about the reliability than the power. Power's easy.
We're not
this next question is perfect for you because you love this one. Go ahead.
Yes. I was thinking about that, Mischa, because actually this next question is related to the previous one. You already addressed a little bit of it, but I'm particularly interested on this one, okay? For two reasons. Mischa and I were going back around the world in this helicopter. I thought about this. So Mischa, thank you, Keith, for addressing the question. But this is from Mischa and I, okay? How reliable will the engine be on large bodies of water en route to your destination? We need that reliability. So how reliable would that engine be on those crossings of the large bodies of water?
So this engine is going to be subjected to all of the certification tests that are required and have been proven over many years to demonstrate the reliability that's required for aircraft. On top of that, we will have engines on the test bench for many, many years to come to keep our engines ahead of the fleet all the time and to sort of shake down as many of the problems that would ordinarily drop out in the early years of service. There is no substitute for field experience. So the aviation community at the moment has the choice between an engine that was designed in 1957 and has millions of hours, and we know how reliable it is because it's been there forever, or if you want the higher fuel efficiency, if you want the higher power, the ease of starting, we have to design something new, and then we have to go and earn those flight hours. Now, as a manufacturer, we will be keeping our engines a long way ahead of the fleet, and we will be shaking down all of the problems that we can as early as we possibly can, and spending an awful lot of money doing that. So we will have done absolutely everything that is technically possible to assure the reliability of that engine. I will be happy to fly in it myself before I send you boys over the water.
There you go.
Thank you.
That's the one I was waiting for.
The helicopter doesn't know that you're.
But I'm a bit of a risk taker.
Yeah, here we are. I think everybody that flies helicopters has to have that risk-reward ratio for sure. But as Mischa said, exactly. When we're going around the world, we thought about this many times. We did 35% of our round-the-world trip over the water, and you know what? The helicopter does not know it's flying over the water. So the same thing, water or land. It doesn't know. It's like exactly. we know, but the helicopter doesn't know. Go ahead, Mischa.
The next three are actually just compliments, so I'll just quickly summarize them. One from Nelio, the dream becoming reality. Congratulations, Jason and entire team. From Corey, thanks, Jason. You're a true ambassador. And all of this is with still no gray hair, which is great. And then from David,
I have.
It's quite clear, Jason.
I have.
Yeah, there we go.
He's wearing glasses.
It's quite clear.
Yeah, and my eyes have packed up.
It's quite clear that Jason is a true professional and almost a genetical engineer. But the question, next one, is do you have an update on the blades and the blade folding system?
So blades, yes. I'm deep into that myself at the moment. So I'm doing the structural design, the aeroelastic optimization, and all of the dynamic design of the blades and the hub at the moment. In terms of the blade fold, again, that will come a little bit later. We have a basic scheme for that, which is totally consistent with what we've been saying all along, that it will fold outside of the hub cowling to keep it nice and simple. But beyond that, we haven't detailed that yet. There's a lot of more complicated stuff that we need to get done sooner so we can get these blades on the test stand and build some experience on them before we need to go flying.
Okay, Hercules is asking, when will press reviews begin? I assume previews of the helicopter, of actually flying. Would love to shoot a video of the aircraft for automotive site. So I think you can address that, but it's quite obvious when would that happen?
Yeah, so again, you have to remember the early prototype will be a proper experimental aircraft. It won't have an interior because we'll have it fully instrumented. We need to get at all the bits and pieces to see how they're performing. So we need to clear off the first batch of flight tests and get to the point where we're approved to do that kind of thing. So I think in reality it will be around the same time that customer deliveries start. There will be increasing amounts of large-scale aircraft hardware around the development center as we go through the year. So in terms of experiencing what the aircraft's like and seeing the full-scale airframe, we'll have airframes here that can start that journey and can let people engage with them. But to go and fly the full-scale aircraft, I think realistically it'll be about the same time that manufacturing starts.
Ricardo's asking about the first trial flight. Can you give us any updates on that?
Yeah, we're still in broadly the same position. I don't have any information that gives me reason to change that. We're still expecting early next year for that. It relies on everything that we're doing continuing to work well, but that's what we're targeting.
Right. Any updates on implementing the floats?
No, sorry, I genuinely haven't done that yet. It's another one of those things. There are other things that are far more urgent at the moment. We have a basic scheme for what we're going to do with them, but it hasn't been developed in detail yet. There's a space claim in the airframe, so they haven't been forgotten. They will work the way we say they're going to, but the detail of the system hasn't been touched.
Okay, and on this next one from Emiliano, I'll just go over it a little bit because I'm not sure if you're staying up to date on those numbers as well, but it's basically asking what is the cost per flight hour. So right now we're quoting $272 an hour, but we do have to update that. We've been looking at updating that in the last few weeks here just because the cost of fuel has gone up quite substantially in the last little while. So you might want to take into the recent inflation in fuel costs, but that's what we're quoting at the moment, $272 an hour.
Yeah, fuel has gone up sometimes like 50%. It's considerable.
Yeah.
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 All right. And the next one is, can you tell us more about the rotor and rotor head?
Yeah, the rotor, I've got to be a little bit careful here because we've got some novel things in there that we haven't protected yet. But essentially, it is a novel take on a what we call an orbital elastomeric hub. So it's a spherical elastomeric bearing, composite blades, and then a very neat way of packaging the structure within the cowling, and a very neat way of getting the blade root out of the cowling. So we've got a very, very elegant implementation that we need to seek some protection on before I can tell you too much about it. But that's coming along very nicely. I think to all intents and purposes, if you consider it to be similar to the EC120 or the Cabri hub, that's broadly what it will feel like from a flight dynamics point of view. The implementation's slightly different, and we use our own bearings, but other than that, it's broadly the same.
Good. And Antonio is asking what the current sales numbers are. So for Antonio, we're at 462 HX50 sold, and currently 97 HC50 sold. Obviously, only 2 HX50 customers at this point, so that's where we're at right now for that. And Charles is asking, have you worked with financiers in educating them about the aircraft?
Yes, so there's a couple of peripheral things actually that I should have put in my presentation and I forgot about. Yes, we're talking to financiers. So we've talked to Close Brothers in the UK. So all of these things have to be done territorially around the world. So in the UK, Close Brothers are one of the leading financiers for helicopters and light aircraft. They're very positive about the program. When the aircraft is in service and has its approvals, they would be more than happy to look at financing it for customers. And so the route to conventional aircraft finance is there. I'm still keen to pursue something on perhaps more aggressive terms for customers as well, to open up the market a little bit more, but that will have to come later. But the feedback that we've had from financiers in the UK is that it's eminently financeable, and the very fact that we've got so many orders means that they're obviously very interested. The other thing I wanted to update you on is that I know I've said in previous presentations that the combustion system is being designed for the drop-in sustainable biofuel alternatives to jet fuel, and I think this is going to become an increasing issue for private owners and also for commercial operators, where we need to demonstrate that we're substantially carbon neutral, and the engine has been designed to facilitate that straight away. We had an amazing meeting with a company that is actually developing a very cost-effective process for producing a drop-in jet fuel alternative, and so that stuff is marching towards completion at about the same rate that we are. So I have every confidence that very quickly a sustainable kerosene will be available for people to be able to purchase. It may be a little bit more expensive to start with, but that will settle down, and that again substantially helps our environmental credentials. So that I think is worth noting as well.
Good. And from James, excellent. What support will you have available in the US?
It's a fairly frequently asked question. In the US, to start with, every aircraft is sold with a mechanics course. So whoever maintains your aircraft at the moment, or whichever aircraft maintenance organizations you have in your area, that you can send them to our factory. We will train them at no cost to them or you, and then they can maintain your aircraft in the field, and they have access to our maintenance portal, so we can support them from the factory. So it's a completely joined up process. You get full support for your aircraft in the field wherever you are in the world.
Excellent. And then we're obviously going to be establishing more prominent service centers throughout the US as well, where all the density hotspots are that can be stocking parts and so forth as well.
We have a lot of applications from all over the world. Constantly, every week, somebody wants to be a service center for helicopters. So that's going to be a sign later in 2023. Next question is addressed to me. It's a hi, Ruben. According to my calculations, to fly this helicopter around the world, it's going to cost about $300,000 in fuel. Is this accurate? I'm figuring out on a budget to do this. By the way, I watched the Epic World Tour. All right, so no, that's incorrect. It's not going to be $300,000, and that's way off. It's about at 100 knots. If it's going to be consumed the same as the 66, pretty much. If you're going to go faster, it's going to be more. It's going to be about 27,000 liters, which at now current rate about $2 a liter is going to be $54,000. So budget in between 50 and 70,000. You're going to be good going around the world if you do the same route as Mischa and I did.
Perfect.
And then the next one is there? Yeah, go ahead, Mischa. Okay.
Sure. So it's from Alex. Is there any chance that we could get a automatic blade folding system so that you could blade fold with an app, or while you're in the cockpit?
Yes, it's on the list of things that we're developing, so that will come.
Okay, and then we have from Joseph, will there be, we will be able to fly the HX50 or either on X-Plane or Microsoft Simulator within the next year?
Possibly.
That one is answered.
So no, we may have reason to do that over the course of the next few months or so, and if we do, we'll also make it available to the community.
Excellent. And that question was from our good friend Joe, Ruben. Remember from the World Tour, Joe, that sent us messages when we were flying through Florida. So thanks.
Oh yeah, just recognize. Yeah, Mattern for sure.
Yes.
Joe.
Yes. The next question is from Rashad. Are you accepting investments from non-accredited investors? If so, please direct me to where I can contribute.
That's a very kind offer.
No and yes.
Yeah.
Jason, no and yes. Go ahead.
Yeah.
Yes, indirectly.
It's a very kind offer, but we don't need investment. We're entirely self-funded, and we have plenty of money. However, if you wanted to support the program, you are welcome to buy a helicopter.
Or more.
There you go.
Or more, yeah.
Several.
Accepting orders, yes. Excellent opportunity.
Yes.
And next one is mine, yes. Eddie, You mentioned ForeFlight and Ozpilot. Will you also be integrating SkyDemon and HeliPaddy?
Yes. SkyDemon, yes. Runway HD, yes. I think we polled again. This is one of the benefits of our approach. So we have a customer app, and we polled the customers across the world as to what apps they used. They fed that back to us, and then I took that list straight to Martin and said, "Make that work." So all of the apps bar two currently work either on Android or on the M1 environment. And I think when the developers see the opportunity, and I think ForeFlight are taking a very open-minded view as to what this might do for new opportunities for them as well, when they see the different way that their product can be delivered to market, I think many other people will follow as well. So yes, I think lots of apps will become available in that ecosystem.
Perfect. Next question is from Keith. Will there be a sensory notification, so a video feed of the aircraft being walked around or tampered with, video recording?
There's no plan to do that at the moment. And this ties into a broader theme that we've got across the aircraft, which is we need to keep the aircraft as simple as possible. Anybody that's owned a nice car will know that you, after the first couple of years, are plagued by lights coming up on your dashboard telling you that some sensor's detected something or some sensor's broken, and it will drive you crazy. Now, our aircraft live a lot longer than cars. You know, a typical car lives 10, 15 years. Our aircraft are going to live 40 or 50 years. And those sensors are just not going to be reliable for that time period. So if we just threw sensors around everywhere to have the thing fully geeked up, it would just cause us a nightmare and cause each of the owners a nightmare down the road. So again, there's a difference between what you can do in aircraft, what's practical to do in aircraft, and what's practical to do in cars. So for that reason, we're trying to keep the sensors down to just those that are absolutely necessary.
Okay, next question is from Carlos. It says, will you have ready to deliver units? I think we can all answer that, yes. But
yes.
You can add a little bit there, probably, Jason. But yeah, the second part is, what is the lead delivery time that is being considered right now? So we are right now in the 400, mid 400s. So that means in 2025. The sooner you order, the sooner you will be on that schedule of delivery. Do you want to add anything there, Jason?
I think the only point that I would add to that is we continue to be responsive to the market needs. So I think anybody considering ordering at the moment shouldn't be put off by the wait, because go and try and buy a Porsche 911 Turbo at the moment, or go and try and buy any sports car. People are waiting 2 and 3 years for lots of luxury goods. But from our perspective, then if the demand continues to be high, then the factory will be configured accordingly. It's clearly not good practice for us to go into this having years and years and years of orders in front of us, because they won't get to maturity if we leave them too long. So as the demand continues to grow, we will upscale the factory faster. It's a self-solving problem. The more orders we've got, the bigger the factory we can build.
Good. Next question is from Steve. Will telematics be factored into the insurance cost? Flying within the conservative envelope dramatically lowers the cost for the next quarter. Flying like an idiot raises your costs.
Absolutely. So one of the things that is important to me is that we give private owner operators that are operating often away from an instructor or an examiner for a year at a time, the same level of ownership support that a pilot would get if they were self-fly hiring from a flying school, or if they were a line pilot with a commercial operator. And we're going to deliver that through the sort of flight data recorder, through the app and the active safety management system. And what that means, and this is by no means intended to feel or be a black box on an 18-year-old kid's car dashboard. You know, that's not the purpose. But in helicopters, the stakes are a lot higher. If you develop bad habits, if you become complacent or overconfident, that can kill you in a helicopter, and that's no good for any of us in the community. It's no good for my brand, it's no good for your factory, and it's no good for anybody that's involved, or the insurers, you know, that inevitably pick up the tab. So we are using that data, but we're using that data in a positive way, that if people start to develop flying characteristics that would suggest they're likely to have a problem, then we can offer support, we can offer time with instructors, we can intervene before it becomes an accident. So the exact rollout and nature of that program is yet to be defined, but the systems are there to be able to do it, and we will benefit from preferential insurance rates because we provide that level of support to pilots.
All right, next question is, will there be an auxiliary power accessible from the battery reserve, or either a plug-in for a small generators providing short-term power for certain comfort, like heated seats, phone navigation, entertainment when a business meetings, when few minutes need to be burned? So around it, when the aircraft is on the ground, could be.
So I'm not entirely sure I understand the question. Are you asking me if you can plug the aircraft in on the ground, or are you asking me if you can plug something into the aircraft when you're inside it and it's on the ground? So we've got the answer.
Plug the aircraft on the ground so it can have access to certain entertainment. You're not draining the battery, and
yes.
You can have
it comes with a ground power receptacle as standard. So you can trickle charge the batteries, and you can run a number of the systems while you're on the ground. There's a limit to how much power you can draw through these things, otherwise the cables get enormous. But yes, there's ground power available, and there's USB receptacles all the way around the cabin as well, so that you can plug stuff in from every seat position.
Another question from Canada here. While you're actively working with the CAA and EASA, and you had some initial discussions with Transport Canada, have you been looping Transport Canada in on any of the further engagement that you've been doing?
No, is the simple answer, but for no other reason than the stuff that we're doing with the CAA at the moment is very based on the organisational approvals. So it is very UK centric. And then once we've got those approvals in place, we then have the right to produce the data that can go out to all of these other authorities around the world. So the most expedient way through all of this is to get all of the first stuff done and tied up first, and then as we come to the end of that process, not wait till the end, but as we approach the end and we can give them a concise pack of information, a certification basis, and all of these sorts of things, then to bring them in. They'll be much more looped in on the HC program than they need to be for the HX program.
And Federico, one of our newest clients, has a question has already been addressed, but I think you can address it again. Why not? When will you have the first aircraft ready for a trial flight?
Same answer as earlier, early next year.
That's it? All right, that one.
From Keith, what things would you advise future owners to do in the preparation of the receipt of their aircraft? Helipad registration support, things like that.
Where is Keith in the world? Not that it matters that much.
I'm not sure, actually. I have to look.
Okay, well, it depends on your current status. If he's an existing helicopter owner, keep flying, keep enjoying flying, keep on top of your skills. If you're planning to keep your helicopter at home and you need to build a hangar and things like that, I think our experience to date from most parts of the world is that it's generally quite an awkward process. So get started on that as soon as you can, because the planning authorities can be quite difficult. In terms of registration, you don't really need to do anything on that front. In terms of the approval of the aircraft in each of the territories, that is very much with us, and we won't push that out until we've finished the development of the aircraft, because you need to go into these things with a clear definition of what you want from the authorities, a clear definition of how you've met all the requirements, and a set of information that demonstrates that. So I don't think there's a lot that anybody that's in the queue needs to do other than enjoy the process and keep flying as much as you can.
Lee asks, will the FADEC software have dual redundancy channel? And will the engine and rotor governing be optimized to minimize torque spikes due to power pedal inputs and rolling acceleration?
Yes, to both of them.
Great. The next question is from Carl. I think it's more of a question for you and I, Ruben, but it says, will you be able to go around the world without going through Russia? No. That is a challenge. So if things are
you can't do
the same
a
as they are right now,
you can't do a
circumnavigation.
But our plans, we're not planning to do a circumnavigation necessarily. We will have to come back to the same spot, but we're going to demo the aircraft. This is important for the project. We're going to demo the aircraft. It's going to be everywhere in the world as much as we can. We're going to be spending time to demonstrate the aircraft. So we're going to go to many places we have not been there before. So we don't need to go to Russia if we can't. We want to go to Russia. Depends what's going to happen then, but we don't need to. So we're going to go through Asia to Australia and then New Zealand and come back the same route. But that will be a little bit different, but it's possible, yes.
Yeah.
All right, and next is Keith.
Go ahead. Yeah.
Yep. Keith is, will there be a build program experience filming owner footage throughout the build process? Oh, interesting.
That's a really good idea.
Easy one.
That's a really good idea. Yes, we'll do that.
Documented
Josh, I've got a job for you.
Thank you,
yes,
Keith.
we'll do that. I think that's a great
this,
idea.
Right?
I mean, one of the things that we have to do is we have to maintain very, very tight records of who does what during the build process. So we have to record that. There'll be standard cameras in each of the workstations so that we can record each of the opportunities to produce the build documentation. But that's not the same as a sort of memories video, you know. So I think yes,
exactly.
we should do that. That's a good idea.
Mm-hmm. Yeah, excellent idea.
Gregory is asking, what do you expect the manufacturing capacity to be per year?
It depends on how many we sell. It depends very much on how the orders continue now up until the point that I lose the ability to upscale the production building. But I would expect around 500 a year with an ability to scale up to 1,000.
Nicholas
but
is asking,
it will take a while to ramp.
Nicholas is asking, are you working on patents yet? Well, are you working on patents?
We've yes is the simple answer to that. We've got a bunch of them in progress at the moment. I haven't fully made my mind up on what our IP strategy should be, because patents get very expensive very quickly, and I'm not entirely sure how much protection they would give an organization of our size in a market of this maturity. So I might take a slightly different response to it. Although I appear like I'm being very transparent about what I'm doing and how we're doing it, I'm really not telling you the clever stuff. And I think keeping some secret sauce is probably the best way to do it.
That's great. And will there be a pull down or pull out tray, as in a private jet, where passengers could pull out for eating or using items from the refrigerator or computer?
We haven't made any provision for that at the moment, other than the refrigerated center console in the armrest that's accessible to everybody. So you have a small refrigerated area there, but we haven't done anything else yet. That said, it's a massive cockpit, so there's no reason why we couldn't do that. I just need to get the thing to fly first. Then we'll come back and do all of those nice to haves.
Right, and I want one of those. Mischa doesn't want. This is a private joke. Mischa doesn't want one of those. He doesn't care about that. I want one. You know that, Jason.
Yeah.
I want the refrigerator. It's really convenient here.
I'll put a note on your file.
He only flies in. Yeah, he only flies in cold places. That's his problem. Yeah, but when he starts flying in Costa Rica, that would be nice. Yeah. Okay, and Roy asks, will there be an indicator on the dashboard if one of the doors is not properly closed?
I should apologise. Roy made that question on the app and I forgot to respond to him. So I would have answered that no, for the same reason that I answered earlier. But I've been bullied into putting those sensors onto the doors by a couple of other members of the team. So as it stands at the moment, we will have door closure sensors for a couple of technical reasons. So yes, we will. That will also then facilitate an interior light for when you're loading passengers at night and things like that. And I know there's all sorts of things we've got to manage with night vision and stuff like that, which we will do. But yes, there will be sensors on the doors, so you'll know that your doors are shut and secure. Sorry, Roy.
Excellent. Michael is asking, will it be ideal for maritime operations? I'm guessing this is meaning more for like coastal operations.
So it depends what you mean by ideal. You know, it's a very capable 5-place helicopter with an 800 kilo payload. It's fast. And it's got a flexible cabin. The design is designed to be as resilient in maritime conditions to corrosion as anything that's out there. We've got state-of-the-art corrosion protection measures in there to protect the metal bits and a composite structure. So I think it will be very resilient in those environments. So some of our earliest customers are in coastal locations or hot and salty locations, and so we've done everything we can to make sure the machine's robust in those conditions. But would it be ideal? I don't know. It depends on your specific application and whether it's private or commercial.
Moritz is asking, I am a helicopter mechanic and I want to work on the HX50. Is there any kind of database where owners can find me? And what will be the maintenance program look like?
Yes.
Interesting.
So what we will do through our app and our owner portal is provide a portal to everybody that's qualified by us on the aircraft. So qualified examiners around the world, qualified safety pilots around the world, qualified instructors and qualified mechanics. So once you've been to our training courses, you can have a profile on our app where our entire user community can find you, and you can promote your own business interests within there. Our objective is to make it as easy to get HX50 supported both in terms of flight and in terms of maintenance and operation around the world as we can. We don't intend to have in-house facilities around the world. That's going to go out to the established people that know the local markets, know the local territories and know the local people. So we welcome all of those people and we'll promote them from within our portal. You have got to do my training.
You guys, we're getting down to the last few questions here. So if you guys have any more questions that you would like us to ask Jason, make sure you're putting those in the chat right now, because we're rounding down to the last few here. But Jason, this is a fun one for you. It's from Michael. He says, Dr. Hill previously mentioned his infatuation with Airwolf Helicopter Show. Did Dr. Hill know that there was an Airwolf episode titled HX-1? And if so, did that have any influence on naming the helicopter HX50?
Yeah, I did know that because I'm terribly sad, but it didn't. The H and the X come from Hill and experimental, so it's a very boring engineering name. And the 50 is 5 seats and 500 horsepower. So yeah, it's an engineer's best attempt at branding.
All right, Isaac is asking a very important question. Does the rotor design safeguard against mast bumping? Recently,
Yes.
there have been a few accidents where the main rotor sheared off the tailcone.
So mast bumping can only occur in two-bladed helicopters. It is not in any way limited to a particular manufacturer. It happens on all helicopters that have two blades. And the fundamental reason for that is in a two-bladed helicopter, you are dangling beneath the rotor. And the only thing that holds the fuselage in the right orientation relative to the rotor disc attitude is the weight. Okay. Now, when you go to a multi-bladed rotor, and it doesn't matter how many blades, The moment you move your flapping hinge away from the rotational axis of the rotor, you end up having a centrifugal moment that will act like a big spring that tries to keep the fuselage in the same orientation as the rotor disc, okay? So there's a fundamental physical force that keeps the fuselage where it should be in addition to the weight of the helicopter. So fundamentally, you cannot have mast bumping in an articulated rotor, in a spheriflex rotor, in a sort of elastomeric rigid type hub. None of those suffer from mast bumping. Some of the old articulated rotors could suffer from things like droop stop pounding, which is where you exceed your flapping allowances and thump the retaining features in the hub. But the modern hubs don't do that at all. So our reason for choosing a 3-bladed rotor system was that we get this far superior handling qualities, and 3 is the smallest number after 2 from a cost and a practicality point of view. I would have liked to have 5 because they sound a lot better, but it makes folding the blades more difficult, the costs go up, the donut in the center of the mast becomes a bigger diameter and hurts my drag. So fundamentally, you can't mast bump. You'll have much better handling qualities in the wind, in turbulence, and it'll be much easier to handle from an inexperienced pilot point of view.
Okay, and the next question is from Andrew. Will there be a water wash manifold to help mitigate saltwater corrosion on the engine when flying in coastal areas?
Yes.
Okay, that's answered.
Ruben, I think
and
you have
actually,
the last one,
Steve brought but Steve brought a good idea. Hey, get to Discovery Networks to film the HX50 story, or Netflix like they did with Elon. That's a good idea. Let's work on that. Very good. And actually,
we're seeing what we can do.
Part of being following along this journey, and we have had a lot of those situations, is we really have an incredible community of support. So if any of you are watching this and have connections and have an idea about this, get in contact with us, because there has been some projects that have really started this way. So we have a great network of people right now all over the world. So get us connected, and we'll be very interested. Next question will be from Marlene. Will it have the ability to tell the pilot or other aircraft flying in close proximity to you when you're flying?
Yes, it's got traffic based on ADS-B in and out. So it's got a basic traffic system. And then, of course, a lot of the apps these days are offering additional traffic protection mechanisms as well from various external sources. So yes, it has a traffic system. The only thing I would say to that is you have to bear in mind that none of these systems are perfect, and there isn't a lot that protects you from an aircraft that doesn't carry a transponder. So the pilot is, and for the foreseeable future, will remain responsible for looking out for traffic, but we'll do everything that we can to make that easier.
Okay. And the next question is from RJ. When will a desk model be available? So we have that available right now. You can contact us, RJ, offline, and we can get you the link for where you can order that. I have one sitting on the desk at BC Helicopters, and it looks pretty amazing. They've done a very nice job with it. So the next question is,
by the way,
this
is not our business. Mischa, just want to think, this is not our business. It's really a specialized company, and Lydia can put the link there. If Lydia has the time, she can put the link on the chat, and you can follow that link. Anybody can buy directly from them. So they really, really, really look nice. They're really well done. Very nice.
Yeah, super quality. Pascal is asking, on 400 hours a year owner operated, what is the average operating cost? That's a little tougher to answer. As we talked earlier, Jason, I don't know if you want to comment on that. It's about $272 an hour if you're flying about 100 hours a year. And that was based on fuel costs as of about 6 months ago. So that's probably gone up a little bit now, or it has gone up a little bit now. But if you're going to be flying at 400 hours a year, you're going to start to see that cost come down a little bit because things like your insurance and so forth are obviously going to be reduced a little bit per hour. But Jason, if you have any comments on that.
I was trying to do the sums in my head, but I couldn't. I'm too tired.
Yeah. I think looking at US dollars based.
fundamentally, the more hours you fly, you start to wash off your fixed costs. So your insurance cost gets washed off over a bigger number of hours without a material increase. Your maintenance will go up slightly, so because you'll need an additional 300-hour inspections, but not a significant amount. And then it depends whether you keep your machine at home or whether you have to hangar it. But I think your fixed costs start to become far less significant. It then just comes down to what the price of fuel is locally to you, and that's entirely variable. So if we could provide a little worksheet or something like that so that you could have a reasonable stab at it, but it'd be your local numbers that drive that more than ours. All I can really say is, for most private owners, it's the horrendous fixed costs that drive the cost of ownership. And HX50 and Hill Helicopters is all about a root and branch review of that and how we control those factors. So lower cost insurance, lower cost maintenance. We've dramatically reduced the depreciation with the 5,000 hour life and on condition. So all of the things that really contribute to the cost of running a helicopter privately become vanishingly small when you're running 400 hours a year. And your fuel costs will then start to dominate. So we could help you work that out, but it would need to be done on a case-by-case basis.
And then Alejandro is asking, the turbine will have some anti-sand filtering system, different from a particle separator. This filtering system, will it reduce the performance of the helicopter?
There is always a performance hit when you put a filter in the system. So that is built into our performance model. So there is an inlet barrier filter, and that's taken account of in our performance modeling.
Okay. And at the moment, our last question here today is from Martin, and it says, "Are there any passenger restrictions imposed by the permit to fly certificate?" No, not in this case. So that again all comes down to the basis for approval. And if your basis for approval is the full certified standards, then other than commercial use, you are entitled to the operating privileges that are conveyed by that code. Okay.
All right, I think that
Wonderful.
We're reaching the end here, Mischa, and we had more than 1,200 people watching this event live today. Very, very good. Thank you very much for all your support from all over the world. And we're also going to have our next session. But JC, you want to say something before we close?
Yeah, I was just going to give a shout out to Don Bondi, who's not been very well recently and has been following us through the app and has been, he said he was going to try and stay awake long enough to watch this tonight. So if you're there, Don, hope you're well. Look after yourself and thank you for your support.
Thank you, Don. Absolutely. Mischa, you want to mention the next date of our Ask Me Anything session, monthly update?
Yes, absolutely. So we are planning our next one. I don't want to get this wrong, so I'm just going to check on the 21st of June. So the 21st of June is the next AMA session. We're going to be sending you guys links for that, so you don't need to put that on your calendar yet if you don't want to. But we'll be sending you lots of information on that one coming up.
Is that a different date to what you told me earlier? Am I invited?
No, it was updated. It was updated.
Okay.
Recently updated, yeah.
Yes.
And by the way, this is important also to mention that this will be the last update before our big second event. So we're going to have the second event on the 11th of August. And that's going to be our second global meetup and discovery event in Rugeley Development Center of Hill Helicopters. All the owners are invited. We still have some seats there for you and your guests. And anybody that has not ordered an X yet, you can order an HX50 so you can go to the event. And if you're going to order after, no problem at all. You can watch it live through the internet. So you're going to have that access live, all as we did, the same thing as we did the previous one in December. Hopefully, we're going to be able to see you there in person. And Rugeley, Mischa and I are going to be there. And it's going to be, we're looking forward to this event a lot. Jason, you don't want to just unveil anything about that? Not yet, right? But there's going to be a lot of good stuff to show there, right?
No teasers.
No, I'm keeping tight-lipped about that, but I suggest you book your plane tickets now.
There you go. That's
We
a
have
good suggestion.
we have a lot of the
Absolutely.
seats. Yeah, we have a lot of the seats already booked at this stage. So if you are planning to go to that and you haven't booked that yet, I would suggest going to the link there that we've provided and getting your seat registered. And if any guests that you're going to want to be having as well, get those people registered as well, because it is going to be limited seats. And the further we get along here, the more people want to be attending these things. So.
Very good. Well, thank you very much, all of you from all over the world, all continents. And great to have you once more time. And next June, the 21st of June, and then for the AMA. Thank you. Have a great day, afternoon, evening, wherever you are in the world.
Thank you, everybody.
Again,
Good night.
Thank you.